Hi dear students, good morning. In the last class we already discussed the basic components of forces, the definition of the force and some of the examples of the force, what we are doing in our daily life, that about already we discussed. That means we got some of the idea about that force. That means push or pull. Otherwise both also we have to consider as a force. Push also force, pull also force, otherwise push and pull both also we have to consider as a force, and we got the lot of examples in the last class. I already told you people you have to write the sum of the example for push, some of the example for pull, some of the example for push and pull. This everything also force. What we are doing in our daily life, everything also force only. Suppose while we get up in the morning, we have to start our daily life with brushing. As before brushing, what we have to do, just we have to take the toothpaste tube and open the cap. Okay, just open, and we are applying some force behind of the paste. At the time what will happen, paste is coming out as it is, we are keeping on the brush. That's mean we are applying some force. That's mean we are keeping in our hand like this paste tube, we are catching and pressing. At the time only it is coming out. That means this is in a paste tube and hand. These two substances also interacting directly to each other. When the two substances are interacting directly to each other and applying some force on these, at the time what happened, the paste came out. Suppose without applying of any force, just you have to keep in your hand and keep aside the brush. Just you have to tell come out, come out, come out. Will it come out? There is no chance to come out, because of you should apply the some force on the paste. At the time only the paste is coming out. That's mean our hand and paste tube both also directly contacting to each other. When the two substances are contacting to each other, at the time I am applying force is contact force. That means two substances are interacting or contacting directly. At the time we are applying force is nothing but what? Contact force. Okay, like that. Just you have to remind your childhood. We played with magnets and small iron nails. At the time what happened, when we keep the magnet, it's directly attracting the nails towards itself. Directly attracting the nails towards itself because of without contacting. Suppose this is in a magnet, these are the nails, just you have to assume maintain some distance. There is no contact in between of these two. There is no contact in between of these two. At the time what happened, these all small pieces of the nails are attracted towards of the magnet without contacting. That means without contacting, what happened, they are attracted towards of this side. Some kind of the force is working in between of the two substances. Two substances are not in contacting, but working the some force in between of these two substances. That kind of the force we have to consider as a non-contact force, otherwise field force, otherwise field at distance. Yes, when the toothpaste applying the force on the toothpaste, that is contact. Two substances are contacting to each other. Here magnet and pieces of the nails, there is no contact in between of these two. Here working force is contact force, here working force is non-contact force. That's mean field force. By these what we are concluding, the forces are classifying into the two categories. One only contact force, again one only field force, otherwise force at distance. One only the contact force, again one only the force at distance, otherwise we have to call as a field force. We have to call as a what? Field force. We got the two examples. Yes. Again, apple is falling on the ground. Is there contact in between apple tree and the ground? There is no contact, but apple is falling. What? How? Without contacting, some forces are working in between of the apple and the earth. That also one kind of the example for the field force. Yes or no? You are carrying the bucket with your hand. Just you have to leave it. What will happen? Bucket will fall fall down, that means your hand and bucket both also contacting and you are pulling. Yes, that means it is also one kind of the force. Which force? Contact force. Contact force and field forces. Forces are two types. One only the contact force, again one only the field force. Again the contact force is dividing into the four categories. The field force is dividing into the three categories. As contact force is dividing into the four categories, the field force is dividing into the three categories. The contact force dividing into the four categories. Among that, first one is muscular force, second one is frictional force, third one is normal force, fourth one is tensional force. What I am telling, first one is muscular force, second one is frictional force, third one is normal force, fourth one is tensional force. Along that, force at distance again classifying into the three categories. First only magnetical force, second one electrostatic force, third one gravitational force. First one magnetic force, second one electrostatic force, third one gravitational force. Types of the forces are two: contact, field. This contact force again four types. What is that? Muscular force, frictional force, yes, muscular force, frictional force, normal force and tensional force. This field force dividing into three. What is that? Magnetic force, electrostatic force and the gravitational force. Today in the topic we have to discuss first about muscular force, where we are applying force with muscular, with our muscles, that we have to consider as a muscular force. Just I am writing here what I am using, muscles are using, it is also one of the example for muscular force. You are also writing now when I am explaining, your hands are working. Sir, no sir, I am eating. Yes, you are eating with your hand, that means muscles also working, that is example for muscular force. Sir, I am dancing. Sir, yes, you are dancing with your muscles. Yes, example for muscular force. Sir, I am working in the field, that is also muscular force. When we are applying force with muscles, that all those things are the example for the muscular forces only. When we are applying force on any object, some of the muscles will be contract, some of the muscles will be relaxation. Some of the muscles will be contract, some of the muscles will be the relaxation. At the time the things will be the happening. Sir, I am making bowling. Sir, yes, making bowling. Yes, by the using of the muscles, some muscles are contracting, some muscles are relaxing while you making the bowling. Yes, sir, I am batting. Sir, yes, you are batting. Some muscles are contracting, some muscles are relaxing. These every activity in our daily life, what we are doing is carrying bucket, moving, running, walking, jumping, taking, yes, pushing, pulling with our body of muscles. This all those things are the example for the muscular force. Today your homework is what? Write the few example for muscular force of your daily life. Next one, frictional force. Okay, what is the frictional force? Before discuss the frictional force, just we have to assume the examples. While we play the football in our school ground, one of our friends is kick the ball. What will happen? The ball is moving and stopping. Will it move continuously? There is no chance to move continuously. At some distance it will be stopped. Why it is stopping at some distance? When we kick the ball, what happened? Some amount of the energy transferred to the ball. At the time, by the gain of energy which we transfer from our body by the leg, it is moving and stopping. That means while it is moving continuously, it is losing its energy. When it is start the losing its energy, its velocity will be decreasing. Its velocity will be decreasing. Will it move continuously with the same velocity, with the same speed? There is no chance to move with the same velocity and same speed. While it is moving, stop. After the some time it will be stopping. When it is start from certain place, it will be stop at certain place. Comparing these two places, here the velocity or speed will be more, and at this place the speed or velocity will become zero. In between it is reducing gradually. Because of why? Because of it is reducing, some kind of the forces are working against to this ball. While the ball is moving, some kind of the forces are working against you to this ball. That some kind of the forces are working against to this ball from the ground. The forces are working from where it was working? From the ground it is working against to the move of the ball. These forces we have to consider as a frictional force. Which force? Frictional forces. Is the momentum which prevents the momentum of the ball. Not only momentum of the ball, any object. The frictional force is working against to the any object when it is start the movement. Suppose when it is in the rest position, there is no chance to move. The rest position means simply there only. There is no chance to work the frictional force. When it is start to move at the time against to this, it is working, the frictional forces are working. Which forces are working? Frictional forces are working against to this ball. Yes? Any object which is moving on the path against to that one, the frictional forces will be work. Friction always prevent the momentum of the object. Friction always work as a prevent the momentum of the object. Suppose in our school textbook we have the one lab activity, one tray we have to take. What we have to take? One tray we have to take. On the tray we have to keep the one ice cube, again one coin, again one rubber. Yes, rubber eraser we have to keep. That means one ice cube, one coin, again what we have to sponge rubber, nothing but our eraser rubber we have to keep. Okay, these three also we have to keep on the tray, and just the tray also keep like this. That's mean inclined plane. Like the inclined plane, at the time what will happen? Will the three objects will be moving the same velocity? Will they move the same distance? No, this ice cube is moving more distance. Then coin and the rubber, as it's moving up to here, it's moved up to here. Why these three objects? They have the different distance covered. They cover the different distances because of these three also on the same plane. That means same tray. The surface area is same. But why they did not cover the same distance of these three objects? Because of this ice cube surface area is smooth when we compare with coin and rubber. That means the surface area is smooth, frictional force working is less. Here surface area is somewhat rough than ice cube, so the working frictional forces are more. Here the surface area is completely rough. That means completely rough mean frictional forces will be more. Simply we have to keep in the mind, rough surface more friction, smooth surface less friction. Wherever you go, where there is rough surface, the friction will be more. Where there is smooth surface, there is a friction will be the less. The friction is helpful for us doing anything. Suppose we are walking, running, doing some work or writing something on the paper. Everything is responsible by the friction. Without friction, we can't walk, we can't run, we can't work, we can't write. We can't do any work of our daily activities. Everything is responsible by the friction only. Just we discussed the two concepts, one only muscular force, again one only the frictional force. Remaining concepts we have to discuss in the next class. Thank you so much. Jai Hind.